This is a key to the worksheet on solving absolute value equations where we have variables on both sides. So there were 4 problems, and you had to solve each of those 4 problems. So notice you have an absolute value equation, and on both sides of the equation, you have variables. So let's go ahead and look at number 1. So number 1, you have the absolute value of 3x plus 2 is equal to 5x minus 8. Now remember, in the lessons when we talked about absolute value or how to solve absolute value equations, we looked at problems where we had absolute value equations where on the right side here you had a constant. Now you have absolute value equations where there are variables on both sides. So in our lesson, when we talked about this, we saw that it's very similar to what you did when you had a constant on this side. So once you get the absolute value expression by itself, we're going to split it apart into 2 equations. So the first equation would be 3x plus 2 is equal to 5x minus 8. So remember, in order for those 2 sides to be equal to each other, the middle here, or the expression that's within the absolute value bars, has to be equal to the other side. Okay? And so we have this. Or if this is negative, right? If this is negative and the absolute value of a negative is positive, then we have to take the opposite of that side. And so we have this one. We have R, the R 3x plus 2 is equal to the opposite of 5x minus 8. All right. So we have, so once we get the absolute value by itself, we split it apart in 2 equations. All right. But notice though that when we do this part right here, this 5x minus 8 comes from here, and then on this side we take the opposite of 5x minus 8. All right, and we just solve each of those linear equations. So the ones you have, those 4 right here, once you split it apart into 2 equations, they're going to end up being linear equations. All right, so let's go ahead and solve this equation. So I'm going to go ahead and subtract 3x from both sides. And when I do that and combine like terms, I get 2 equals 5x minus 3x is 2x minus 8. Then adding 8 to both sides, I get 10 equals 2x. And then dividing both sides by 2, I get x to be 5. Okay? Now let's do this one. So over here, I'm going to go ahead and distribute the negative through here. And so I get 3x plus 2 is equal to, and then the opposite of a 5x is a negative 5x, and the opposite of a negative 8 is a positive 8. And then let's go ahead and bring the variables to the left-hand side. So I'm going to go ahead and add 5x to both sides. Remember, what you do to one side, you do to the other. 3x plus 5x is 8x plus 2 is equal to, this is 0, and you're left with 8. Subtract 2 from both sides, and I get 8x equals 6. And then to get x by itself, I'm going to divide both sides by 8. So I get x to be 6/8, which reduced is 3/4. All right, now, you got to be careful because notice you had variables on both sides, right? So whatever value I substitute for x, and I take the absolute value of this side always has to be positive. This side will be positive or 0, but it will never be negative, right? So there's a possibility, though. See, this side here, this side can be positive 0 or negative. But I don't want it to be negative. So you have to check for extraneous roots. So you have to go back and you have to check, and always check in the original problem. That's the mathematical procedure. Always check in the original problem. So let's just check for, so we're going to check for extraneous solutions. Extraneous solutions. All right, so we're going to check the first one, x equals 5. All right, and you always go back to the original. So here was the original. So the original was the absolute value of 3x plus 2 is equal to 5x minus 8. So where we see the variable x, I'm going to substitute 5. So I get the absolute value of 3 times 5 plus 2. And I want to see if that's going to equal 5 times 5 minus 8. Okay? So let's go ahead and simplify the left-hand side. 3 times 5 is 15. 15 plus 2 is 17, right? So I have the absolute value of 17. But remember, the absolute value of 17 is a positive 17. On this side, I get 5 times 5 is 25, and 25 minus 8 is also 17. And notice those two sides are equal. So x equals 5 is a solution. So remember, your statement should have read the solutions is r and then whatever it is. So we're going to write that at the end. Let's go ahead now and check this one. So you must check now x equals 3/4. And notice the work. So always go back to the original. Here's the original. The absolute value of 3x plus 2 equals 5x minus 8. And this time, wherever you see the variable x, I'm going to substitute 3/4. So I get 3 times 3/4 plus 2, the absolute value of that. And I want to see if that's going to equal 5 times 3/4 minus 8. Okay? All right, now 3 times 3/4, 3 times 3 is 9, so that's 9/4, right? So I get the absolute value of 9/4 plus, and then the LCD is going to be 4, so I'm going to rewrite 2 as 8 divided by 4. 8 divided by 4 is 2. And now 9/4 plus 8/4 is the absolute value of 17/4, and the absolute value of 17/4 is 17/4. Now let's look on this side. 5 times 3/4, 5 times 3 is 15, so that's 15/4 minus 8, right? So I'm going to find the LCD. The LCD is 4, so I get 15/4 minus 8 times 4 is 32. All right, 32 over 4 is 8. But 15/4 minus 32/4 is a negative 17/4. Now, before I go on, I want to I just want to mention something, and you should have recognized this. So on both sides, so you see how this is 17 and this is 17? If the math is correct here, if this is 17/4, then this should either be 17/4 or negative 17/4. If you get a different number, if those two numbers are not equal or opposites, then something's wrong with your calculation. All right, so those two sides, when you get to this final step, those two sides should be either equal or opposites at this point. Because remember, that's what you're doing, right? You're setting those two equal to each other. All right, so they have to be equal or opposites. So if you got, let's say this was 5 right here, and this is negative 17/4, something's wrong. Something's wrong there, because those two final values here should be opposites or equal to each other. All right, so those are opposites. I know I did the math correct, and I also know that these are not equal to each other. So what that means is that x equals 3/4 is extraneous. All right, is extraneous. So in terms of that final statement, we're going to say the solution is, and you're going to say x equals 5. All right, and that's what you do. So you solve the equation, you split it apart, and then you show the work. All right, so it's very easy right here to get this part, but then when showing the work, some students mess up because of the calculations, and then they'll get something wrong here and still say the correct answer. But remember, I have to grade you on your work. So if something's incorrect here, even though you get this part correct, you can't get all the points because there's some error in this little part here. Okay? All right, so that's number 1. Let's look at number 2. All right, number 2, we have this equation for number 2. All right, number 2. All right, number 2, we have, the absolute value of 6x, that's an x here, 6x minus 5 is equal to 3x plus 7. So the absolute value of 6x minus 5 equals 3x plus 7. All right, so notice I have the absolute value expression by itself, so I'm going to go ahead at this point and rewrite it without the absolute value bars, just understanding what the definition of absolute value is. So in order for those two sides to be equal to each other, if this expression is positive, then that has to equal this. So 6x minus 5 has to equal 3x plus 7. If this expression is negative, then that means that this and this are opposites. So that means that 6x minus 5 has to be the opposite of 3x plus 7. All right? Okay, so when you split it apart, your solutions will either be whatever we get here or whatever we get here. All right, so let's go ahead and solve each of those linear equations. So let's subtract 3x on both sides. 6x minus 3x is 3x minus 5 equal. And then this is 0, and you're left with 7. Adding 5 to both sides, I get 3x equal 7 plus 5 is 12. And then dividing both sides by 3, I get x to be 4. Okay, so there's one of my proposed solutions. All right, now notice this is a solution to the linear equation here, but the question is it a solution to the original? And so that's where you have to check for extraneous solutions. Over here, let's go ahead and distribute. So I get 6x minus 5 equal, the opposite of 3x is a negative 3x, and the opposite of 7 is a negative 7. And so let's go ahead and add 3x to both sides. 6x plus 3x is 9x minus 5 equal, this is 0, and you're left with negative 7. Adding 5 to both sides and combining like terms, I get 9x equal a negative 2. And dividing both sides by 9, I get x to be negative 2 ninths. So this x equal negative 2 ninths is a solution to this linear equation. Right here, right here, right here, and so on. But is it a solution to the absolute value equation? So that's where you have to check for extraneous solutions. Check for extraneous solutions. And you have to go back to the original equation. Not to any of these, to the original. All right, so let's check x equal 4. Okay, so here is the original. The absolute value of 6x minus 5 is equal to 3x plus 7. So whenever the value is an integer, it's pretty easy to check. When it's a fraction, some students get a little nervous because they're dealing with fractions, and it's natural sometimes to not want to have to deal with fractions. All right, so wherever I see the variable x, I'm going to substitute 4. So get the absolute value of 6 times 4 minus 5. And I want to see if that's going to equal the other side, which is 3 times 4 plus 7. All right, let's start with the left side. Let's work within those absolute value bars. 6 times 4 is 24. 24 minus 5 is 19. So this becomes the absolute value of 19, which we know is 19. Over here, I get 12 plus 7, which is also 19. And notice these two are equal. So I know that x equal 4 is going to be a solution. Let's check x equal negative 2 ninths. All right, so where we see the variable x, so remember we go back to the original. Always go back to the original equation. So where we see the variable x, I'm going to substitute negative 2 ninths, right? All right, so I get the absolute value of 6 times negative 2 ninths minus 5. And I want to see if that's going to equal 3 times negative 2 ninths plus 7. All right, 6 times negative 2 ninths is a negative 12 ninths. That's negative 12 ninths minus 5, right? And then the absolute, now I can reduce if I want to, by the way. So negative 12 ninths, if you want to reduce that, you can. You could say, to make this a little bit easier for you, if you reduce it, they're both divisible by 3. So you could say this is going to be a negative 4/3, right? Minus 5, absolute value. And so the LCD is 3. So this becomes the absolute value of negative 4/3 minus, you want to rewrite 5 as some number divided by 3. So 5 is equivalent to 15/3, right? So negative 4/3 and a negative 15/3 is a negative 19/3, right? And the absolute value of a negative 19/3 is 19/3. All right, now let's go on this side. 3 times negative 2 ninths is a negative 6 ninths. I want to add 7 to that. Let's reduce this. So negative 6 ninths reduced is a negative 2/3 plus 7. So the LCD is 3. So this becomes negative 2/3 plus, 21? 7 times 3 is 21. And the negative 2/3 plus 21/3 is 19/3. Now remember what we said. If you're doing a calculation correct, these two numbers right here, when you get to this point, either are the same or opposites. Okay? So if this let's say was, and you got this right here to be, let's say, negative 14 thirds, and this would be 19 thirds, so you did an error. There's something wrong. When you get to this point, either these are going to be opposites or equal to each other. All right, if they're equal to each other, then that means this is a solution. So we don't have any, so this checks out. We don't have any extraneous solutions, right? So the solutions are, both of these work. These are going to be both solutions. So the solutions are, you're going to say x equal 4 and x equal negative 2/9. Very simple, right? Not difficult at all. All right, now it's number 2. Let's look at number 3. Number 3. All right, so number 3, we have the absolute value of x plus 6 is equal to 3 minus 2x. All right, so I have the absolute value expression by itself. So I'm going to go ahead and rewrite this as 2 separate equations without the absolute value bars. So in order for these to be equal to each other, if this expression, x plus 6, is positive, then that means x plus 6 and 3 minus 2x must be equal to each other. So x plus 6 must equal 3 minus 2x. Or if x plus 6 is negative, then that means that this and this have to be opposites, because the absolute value of a negative is positive. So if this is negative, then these have to be opposites. So that means that x plus 6 must be the opposite of 3 minus 2x. And so I went from an absolute value equation to 2 linear equations. Let's go ahead and solve each of those linear equations. I'm going to go ahead and add 2x to both sides. So x plus 2x, that's an x here. X plus 2x is 3x, plus 6 equal, this is 0. You're left with 3. Subtract 6 from both sides. I get 3x equal 3 minus 6 is a negative 3. Dividing both sides by 3, I get x to be negative 1. So that's a proposed solution. So remember, this is a solution. X equal negative 1 is a solution to each of those linear equations. But the original was not a linear equation. The original was an absolute value equation. So you have to check to make sure that this is actually a solution to that one. Let's go ahead and distribute the negative. So I have x plus 6 is equal to the opposite of 3 is a negative 3. And the opposite of a negative 2x is a positive 2x. Let's go ahead and subtract x from both sides and combine like terms. I get 6 equals a negative 3. 2x subtract x is a positive x. And then adding 3 to both sides, I get x to be 9. So there's another proposed solution. So this proposed solution is a solution to each of those linear equations, but it may not be a solution to the original. So you have to check for extraneous solutions. Check for extraneous solutions. All right, so we'll go back to the original equation. So we have, let's go ahead and check x equal negative 1. So I have the absolute value of x plus 6 is equal to 3 minus 2x. So wherever I see the variable x, I'm substitute negative 1. So I have the absolute value of negative 1 plus 6. And I want to see that's going to equal 3 minus 2 times negative 1. Negative 1 plus 6 is 5. So you have the absolute value of 5, which we know is a positive 5. Over here, I have 3 subtract 2 times negative 1, which means the same thing as 3 plus 2, which is also 5. So those two sides are equal. So that means x equal negative 1 is a solution to the original. All right, let's check 9. X equal 9. The original was the absolute value of x plus 6 equal 3 minus 2x. So where we see the variable x, I'm going to substitute 9. So I get the absolute value of 9 plus 6. And I want to see if that's going to equal 3 minus 2 times 9. 9 plus 6 is 15, right? And the absolute value of 15 is 15. This becomes 3 minus 18, which is a negative 15. Remember what we talked about. When you get to this point, this last step right here, these are going to be either equal or opposites. Right now, these are opposites here. So that means that they're not equal. So that means that x equal 9 is an extraneous solution. So that means That means even though x equals 9 is a solution to this linear equation that I'm pointing to, it is not a solution to the absolute value equation. Because remember, x equals 9, what that does is it makes this side positive, but it makes this side negative. And a positive cannot equal a negative. All right, so the solution is x equals -1. All right. And now finally, number 4. So let's get number 4. So in number 4, we have the absolute value of 3 minus 2x is equal to 5 minus 4x. All right. Okay, so again, the absolute value expression is by itself, so we'll go ahead and split this into two equations without the absolute value bars. So I get 3 minus 2x is equal to 5 minus 4x. So in order for those two sides to be equal to each other, if this expression is positive, then it means that this and this have to be equal. Or if this expression is negative, remember this is negative, the absolute value of that is positive, but this is negative and this is positive, so that means they're opposites. So that means 3 minus 2x has to equal the opposite of 5 minus 4x. All right, so I went from an absolute value equation to two linear equations. So let's go ahead and add 4x to both sides. And so I get 3. A negative 2x plus 4x is a positive 2x. I get 3 plus 2x equal, and that's going to be what, 5? Subtracting 3 from both sides, I get 2x is equal to 2, so that means x equals 1. So this is a proposed solution. It's a solution to each of those linear equations I'm pointing to, but it may not be a solution to the absolute value equation. Over here, let's go ahead and distribute the negative 1 here. So I get 3 minus 2x equals the opposite of 5 is a negative 5, and the opposite of a negative 4x is a positive 4x. Let's go ahead and add 2x to both sides. And so I get 3, this is 0, when I combine like terms, equals negative 5. 4x plus 2x is 6x. And then adding 5 to both sides and combining like terms, 3 plus 5 is 8 equals negative 5 and 5 is 0, 6x. And then to get x by itself, we're going to divide both sides by 6. And then let's go ahead and reduce. 8, 6 reduced is 4/3. Okay. Now, let's go ahead and now remember, this is a proposed solution. So that's a solution to each of those linear equations. But it may not be a solution to the original. So we have to check for extraneous solutions. All right, so always go back to the original equation. So let's go ahead and check x equal 1. Go back to the original. This is the original. So I have the absolute value of 3 minus 2x equal 5 minus 4x. So wherever we see the variable x, I'm going to substitute 1. So I get the absolute value of 3 minus 2 times 1. And I want to see if that's going to equal the other side, which is 5 minus 4 times 1. Well, 2 times 1 is 2, right? So 3 minus 2 is 1. So that's the absolute value of 1, which we know is a positive 1. Over here, that becomes 5 minus 4, which is also a positive 1. So those are equal. So x equal 1 is going to be a solution to the original equation. Let's check 4/3. So x equal 4/3. And here was the original equation. 3 minus 2x is equal to 5 minus 4x. So wherever we see the variable x, I'm going to substitute 4/3. So I have the absolute value of 3 minus 2 times 4/3. And I want to see if that's going to equal the other side, which is 5 minus 4 times 4/3. So let's work within the absolute value bars. So I have the absolute value of 3 minus 2 times 4 is 8. So that's 8/3. And I want to see if that's going to equal 5 minus, and then 4 times 4 is 16. So that's 16/3, right? Okay. So 3 minus 8/3. So the LCD is 3 here. So I can write 3 as 9/3, and that becomes minus 8/3. 9/3 minus 8/3 is 1/3 absolute value, and the absolute value 1/3 we know is a positive 1/3. Over here, the LCD is 3, so 5 I can write as 15/3 minus 16/3, which is what, 1/3? Negative 1/3. All right, so notice opposites, right? So either they're equal or they're opposites. So notice these two are not equal, so that means x equal 4/3 is extraneous. So it's an extraneous solution. So that's what that means. It's a false solution, which means this, which means x equal 4/3 is a solution to each of those linear equations, but it's not a solution to the original, because what it does is this. So x equal 4/3, what it does is when I substitute x equal 4/3, this side's positive, but this side's negative. A positive cannot equal a negative. So that's why it's called an extraneous solution. So the only solution is x equal 1. So the solution is x equal 1. And that's it. That's the solution. All right. So that is the key to the worksheet on absolute value equations where we had variables on both sides.